EET 114, Chapter 15, Series AC Circuits, Problem Example 2. For the resistive element shown in this figure, Part A says write the voltage in phasor form. So the voltage is this is the voltage across it in sinusoidal form. It's V sub R equals 24 sine of 300t plus 20 degrees, okay? So the maximum value is 24, so you're going to take that value and divide it by the square root of 2 to get the phasor magnitude, which is what they did here. And then the phase angle is just going to be this 20, so they put that over here, and 24 divided by the square root of 2 is 16.97 volts, angle of 20 degrees. Part B says calculate the current through the resistor in phasor form. The current is going to be the voltage across the resistor divided by the resistance from Ohm's law. So the voltage we calculated to be this. The resistor is going to be 6.8 ohms, angle of 0 degrees. So then to do the math, this is a complex number. So you take the 16.97 divided by 6.8, you get 2.5 amps. And then the angle is going to be 20 minus 0, which ends up equaling 20. Sketch the phasor diagram of the voltage and current. The book does not do that, but I did it here. So V sub R is going to be 16.97 angle of 20, which looks like this. Okay. And the way we figure that out is, here's the magnitude here and the phase angle. And then the R value, the resistive value, is going to be Z times the cosine of that 20 degrees. You have to calculate the 20 into radians to get it to work in Excel, because Excel only does it in radians. But on your calculator, you should be able to set your calculator degrees and just punch in 20. You're going to get 15.95, and then the X component, which is the vertical component, is going to be 16.97 times sine of 20 degrees, which is 5.8. Same thing with I sub R. I sub R is just this red part right here, and it's 2.35 J, or 2.35 plus J of 0.855, which is also equal to 2.5 angle of 20. And then part D says write the current in the sinusoidal format. So we take this 2.5, we multiply by the square root of 2, sine of 300t, we keep the same frequency, plus 20, which is the phase angle right there, and then that equals 3.53 sine of 300t plus 20. And then part E says sketch the waveform of the voltage and current. So over here I did that. The voltage is this blue line, and it looks like this. And I just used exactly the same formula for here. And then the current, I used the formula for here. And as you can see, they're in phase. They both have the same 0 crossings. Okay, so you know that they're definitely in phase. And they are in phase because they have the same phase angle here. They both have a plus 20 theta, which means they're shifted to the left. Okay, if they were 0, they would both 0 cross at the 0, right at the 0 crossing right here at the origin. And if it, let's just say they were negative 20, so if I put in negative 20, you can see that, well, they should both shift. If they're negative 20, let's make them like negative 45, and they're going to shift more to the left. You see that? So that's just showing you how that works.